Hi everybody, my name is Mtwana Wabantu. Okay, so without further ado, let's get into it, right? So today we're gonna do integral of sec, like all these type of questions. We're gonna do x, sec x, and then I'm gonna integrate sec square. Also, I'm gonna integrate sec cube, and then we're gonna do power fourth, and then we're gonna do power fifth. Okay. Also, we're gonna use the reduction formula. So I wanna show you all these type of integral and how to solve. However it's gonna come, they should be okay. Now, let's start with the integral of sec. Okay, so somebody give you integral of sec x dx. So what you're gonna do, you have to introduce as how you see. This is gonna be integral. So we still have our sec, write your sec there how it is, and then here, write sec plus tan x. So I'm gonna write sec plus tan x dx. And then at the bottom, I'm gonna write the same thing. So it's not gonna have an effect, sec x plus tan x. Means this and this is gonna cancel because then you're gonna get 0. So I'm gonna let the denominator equal to any letter. So let u equal to sec plus tan x. And the next things here, differentiate. When you differentiate u, you're gonna get du. When you differentiate sec, you get sec tan. So this is gonna become differentiate sec, you get sec x tan x. And then when you differentiate tan x, you get sec square x dx. But hey, look careful. If you multiply this, it's going to be sec x squared. So if I had to say, okay, well, if I had to rewrite that one, it's going to be integral sec square x plus sec square times tan x will be sec x tan x. And then we over sec x tan x. Because I want to do substitution here, sec x tan x plus tan x. Okay, sec x plus tan x, and then we have our dx right there. So look, sec x tan x plus sec x squared x dx, all of this equal to du. So this time I say I have my integral sec x squared dx plus sec tan x equal to du. So this is going to become du on top. We over sec x plus tan x. We did let equal to u. So it means I'm going to say over u. So here I can write 1. But remember, when you integrate one of anything equal to ln of whatever you have. But for now is u, and then we plus our constant c because there's no limit. But we know the value of u. What the value of u? The value of u equal to sec x plus tan x. So finally, I'm going to say, if I integrate sec x dx equal to ln absolute sec x plus tan x. We plus constant because we don't have no limit. Now let's check integral of sec squared. Integral of sec squared equal to tan x. If you integrate sec square x dx, this is equal to tan of x. If you go to the integration table, we have a table of integration which is free. You can simply Google it. It's going to give you tan x, and then we plus c because there is no limit here. So that one we're done. So now I want to show you how to use the reduction formula. Reduction formula, if you have a power 3, like a prime number, let's say 3, 5, 7, you can use a reduction. So what's the formula for reduction? For example, if somebody give us integral of sec 3x dx, see, this power is a prime. So we're going to use a reduction here, very simple formula. How does the reduction say? The reduction say, if it's power n, so you need to memorize this, right? The reduction say, let me put blue color here. The reduction is like this, integral sec, if this is power n, if this, let's say, odd number, let's say 3, 5, 7, something like that, you know? And then dx, this time I say, you just memorize this one easy, but I'm going to show you in another question how to derive it, okay? So this time I say, I'm going to say n minus 2 over n minus 1 integral of sec n minus 2 x dx plus, this place is not enough. So, okay, plus, we're going to finish here, plus sec n minus 2x tan x. You know what? I don't like to write things on next line. So let me just write full of it. So let me just expand a little bit. So let's move this part first, and then let's write the whole formula for reduction. So it's like this, right? I'm sure. Reduction. So let's say our power is a prime number. So it's a prime number. So if somebody give you integral of sec, let's say nx dx, so this equal to say n minus 2, n minus 1. Just memorize this, and they say integral sec, but I'll show you how to get there. N, and they say n minus 2 here, x dx, and then we plus sec n minus 2 x, and then tan x. That's why I don't write in a power here, okay? Tan x, and then here n minus 1. N minus 1, n minus 1, only here n minus 2. Just memorize, simple like that, okay? Reduction formula for sec. So what we're going to do here now, by use only for when you have like an odd number. To say odd or prime, odd number. If I say prime, I think it'll be wrong. Odd number, yeah. Odd prime, or you can call it. So I'm going to say integral. Now let's say sec power q. But don't take when it's 2 or 4, okay? Don't use that. You can, 2. But 4, sometimes it doesn't give the right answer. I'll also use power 2, power 3, 5, 7, stuff like that. But a 4 don't. I'll show you why. I'm going to prove to you. I'm going to show you with a question. So now we're going to say dx, c power 3, right? Equal to, now 3 minus 1 equal to 2 over 3 minus 1 minus 1 equal, 3 minus 2 equal to 1. Sorry. 3 minus 1 equal to 2, and this is going to be integral sec. Okay, now 3 minus 2 equal to 1. So I don't have to write 1, x, and they say dx, and then we plus sec. Okay, 3 minus 2 equal to 1, so I don't have to write 1. So say tan x, and then this is 3 minus 1 equal to 2. So we finished, but I would know. Integral sec of x, this one here, we know we did already, equal to ln sec of x plus tan of x. When we started solving the case, we know. If you integrate sec, you get that. So I'm going to come and replace all of this with that. So I'll say this is going to be half. So we integrate sec q. Sec q equal to, we have a half, but an integral of sec x equal to, let's put this, bracket, is a ln sec x plus tan x means integral of this, but we have a half one outside. And these are absolute. Okay? Because we have a ln, it must be absolute. And then we plus whatever you have over 2. So I can say 1 over 2, in other way, sec x, tan x. That's all. You understand? So even if you say, let's say power 2, we know when you integrate integral of sec x squared, it's going to give you tan x. Now let's prove and see. So let's say this is power 2. Let's say this is power 2. So if this is power 2, what is going to happen? Means it's going to become 2 minus 2 equal to 0. So this is going to be 0 here. Okay, let's plug it in and see how it's going to give us. Because we know for facts, when you integrate sec squared, it gives you tan x. So we want to use the reduction formula to see. So even power 2 is going to work, but power 4, I would encourage you to use that. Because for the most case, I'll show you now why. Okay, so now let's use power 2. 2 minus 2 equal to 0. So it's going to be 0 over something 0. 0 multiplied by anything 0. So even if I'm not going to bother here, I know all this is going to be 0 because 2 power 2, let's say 2 minus 2 equal to 0. 0 divided by anything 0. So multiplied by all this is going to be 0 because even if you plug it, it's going to be 0. So it's going to be sec power 0. Like this already make it 0. So we know I don't have anything plus 0. So plus, now we go for the next one. 2 minus 2 equal to 0. So it's going to become sec power 0 and then x and then tan x and then over 2 minus 1 equal to 1. So anything power 0 equal to 1. But in other words, if somebody says sec power 0x, it's going to say sec or power n, it's going to say sec x power n. So it means this power 0 can be on outside. Okay? So sec bracket power 0 equal to 1. So this half equal to 1. Sec 0x equal to 1. So this is going to be equal to 1. So 1 times tan x equal to tan of x over 1 equal to tan x. So 0 plus tan of x because 1 and 1 is 1. 0 plus tan x equal to tan x. So that's why we say when you integrate sec square x dx equal to tan x. You see what I'm saying? Now, so we did power 3, power 2, power 1. So power 4 do not use reduction sometimes because I try to do most of the time. It doesn't come like that, okay? So let me show you how you can do power 4. And then we're going to go for power 5. Okay, now let's check this quick. So power 4, I'm going to show another way how to do it. Let me show you something very, very crucial, okay? Okay, so integral, okay, let me say something, okay, let me just go straight without wasting time. Integral, sec, power 4, x dx. So what I'm going to do, I'm not going to use that methodology, okay? I'm going to use another way. So say this, let me say integral, oh, my pen and get it finished. Okay. Integral, sec square, x, and then times sec square x. Because it does not make a difference. This is equal to sec power 4. So what I'm going to replace this, but a sec square equal to 1 plus tan square x. So I'm going to say this, let me say, integral 1 plus tan square x times sec x. So I'm going to finish. Okay, just go on. Plus or plus. What replace that with that? Plus or plus sec square x dx. Okay, so then we're going to say, I kind of get it finished, but hey, we'll see how far we can go. So we're going to say now, I'm going to let u equal to tan of x, only tan of x. You know why? Because I know when I differentiate tan of x, it's going to give me sec square. So I'll say differentiate this, it's going to become du equal, when you differentiate tan of x, you're going to get sec square x, which is this one right here. Sec square x dx. So this is that. So if I have to replace all of that, it's going to give me du. So I'm going to say integral 1 is 1, but a tan of x equal to u, but a tan of x square means is u square. And then right here, all of this stuff, sec x square dx equal to du. So then we say, we can simplify this. Integral of 1 equal to u. Plus integral of u square equal to u cube over 3 plus c, constant, because there's no limit. So then finally, I know the value of u. So I can replace those u with the right value. What the value of u? Tan x. So finally, it's going to become, final answer, u. What is the u? Tan x. So say the final answer is tan x plus u cube means tan cube x over 3 plus our constant, original plus constant, just because we don't have limit. I want to do power 5, but because of my marker pen is finished, so I'll have to separate and do on different questions. Hey, look, if you face time, make sure you subscribe, share this video to a lot of people, and you can learn from me. I believe you learn from me, and we can learn from each other. Leave the comments. You tell me, your opinion and what did you learn from me and what I can learn from you. Okay. Feel free, raise your opinion, and I'll be very glad to hear your comments on what you think and your opinion. We can learn from each other. Thanks a lot for your time. Peace, and I'm gonna see you soon. If you had to give advice to to grade 11 student, 10 or high school student, as far as how society feels or how to perform better, is condensed, is possible, is condensed that you could advise to them, how would you tell them?
So physics is all about your formulas and obviously getting it right, because sometimes questions can have a lot of detail inside of them. So you have to make sure that you plug in the right values at the right places.
Thank you for giving us clothes. Thank you for looking after us. We appreciate your clothes and your shoes you're giving for us. See that he give us clothes. We don't have clothes, but he's giving us something. He's looking after us.
Okay, Shamil, tell them, when did you last go to school?
I was going last year. Last time I was going to school.
Which grade was that?
I was grade 9.
That was grade 9. Yeah. That's the last time you went to school. So you can become engineer. You can become scientist, right?
Yeah.
I was also on the street. I think I'll tell you every time, right?
3 years you said.
3 years I was down the streets, okay? So I was just like you, okay? I was also on the street for 3 years. But I came out of the street and that changed my life, okay? So, yo, what's up, man?
Yeah,
how you doing, bro? Yo, what's up, man? Hey, what's up? Okay, cool. You see, I was also on the street for 3 years, okay? Say hello to the brother, man. This is my brother, man. How you doing, man? Cool. So I got a lot of clothes for you, okay? You remember I told you I was gonna go and get clothes, shoes. I got some food. I'm gonna buy you some food, okay? Huh? No problem, man. Come on, man. You know brother got your back. What did I tell you last time?
Yes.
Okay, cool. So Shamil, he said he stopped last year, right? Because
If y'all want to reach out, how do we pronounce your name? Let me try. Wait, let me try.
Mtwana Wabantu.
Okay.
Mtwana Wabantu.
Mtwana Wabantu. Okay.
Yes, watching here, they can learn from me that, relationship is very, very important. And, sometimes don't look about today. You might scam somebody maybe $1, but you don't know who that person is. You know what I'm saying?
Well, this is the thing too, that for many a years, I've always been that person to try to link, hook up, pass on, or help people, because I used to know a lot of people, right?
Hore o re thuse re tlhoka thuso ya gago Mr. Mtwana Wabantu ke a leboga. Everyone, my name is Tiko. The reason why I'm doing this video is because of Mtwana Wabantu. It's because of the help of Mtwana Wabantu. Mtwana Wabantu is a nice guy who help people like me who don't afford torture.
And that's exactly what you're saying, is that, these people who are scammers and try to get over on people, and all they're doing is living from day.
Is that Mike? Is that, hold on, it look like some, what's your name, bro, at the bottom right? Mtwana. Right?
Mtwana. I don't know how to say it.
I apologize. My mic was muted. I apologize. I'm sorry.
It's okay. What's up, y'all?
Not much cool. Hey man, I watch you all the time. I just want to give my thanks to you, man. Cause me and my lady.
You said kind of get it.
And I'm going to be working out the net electric field strength on point A, basically.
Thank you. Can you really do those questions?
Yeah, can do
Okay,
it.
let's see. Thanks. So, how did you know all this stuff?
Mr. Hamish taught me all the steps. It was a bit hard first time, but when you get used to it, it becomes very easy.
You had to give advice. Which advice did you give to the people or to the students?
Trust Hamish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Hamish said lots of hard questions, and it's demotivating sometimes to look through the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
How many days have you involved in this program of coding?
Of coding? Well,
Yes.
for 2 days.
For 2 days. Do you enjoy?
Yeah.
Enjoy.
Yeah.
Okay, cool. So let's get into it. So which computer language is this?
Well, this.
So I started coding last year, and the beginning it was very hard. So
This way.
So I practiced a little, and then I was like easier, but it's still tough, but it's still getting there.
And then obviously one question could lead to another question being asked. So you have to take into consideration that you get your first question right before you do the second one, because if you do the first question right, then you have obviously a correct answer. But if you do it incorrectly, your next question that you do could obviously have an impact on the answer that you got in the previous question. So obviously getting the stuff right at the first attempt, and obviously plugging in your values correctly.
Okay.